All this is going to say is I'm starting off with a line that's parallel to a side of my triangle. All right, so I got a line that's parallel. You see that in there? Oh, there it goes. Okay, so line is parallel. What that's saying is if it's parallel, then I know that my other two sides are divided proportionally. What does it mean to be proportional? Same what? Same scale factor, same ratio. Okay? So here, do you see in my triangle how I have that BC is parallel to DE? You see it in my triangle? All right, how do I know that BC is parallel to DE? Well, yeah, how do we know it's telling us? Let's review. The arrows. We're okay with that? All right, all this is saying is if this happens, then my sides are divided proportionally. So start with one side of your triangle and give me a ratio. What two sides are formed here? AB and what? We got AB. What else do we have? BD. All right, so I know AB over BD is going to equal. Now, what's across from AB?
AC.
AC. And what's across from BD? CE. So this is the ratio that's set up right here. So if I have two parallel lines, then I know that these ratios are proportional. They are equal. So I can set them equal to each other. Are we okay with that? Yes. All right. Now with these, we can always set them up and solve them like my similar triangles like we have been doing. But this way is a much quicker way. It's shorter. It's less nasty algebra, okay? Are you ready to try one? You got your ratio down? Okay. All right. What did I need to happen in my theorem for me to divide my sides proportionally? What did I need before I could do that? Parallel lines. Do I have parallel lines? Yes. Yeah. Are we okay with that? Yes. So then I know that my sides are divided proportionally, so I start with one of my sides. What are the two segments I have here? AB and BD. Are we okay with that? What did I do next? Do y'all remember? I did what's across from it. Good. What's across from AB? And what's across from BD? CE. Be careful. Are we okay with that? We sure? Jeremy, okay? All right, pick your head up. Please. All right. Now I plug in what I know. All right, my high school calculus teacher would tell us to plug and chug. All right, what's the length of AB? 8. What's the length of BD? 12. What's the length of AC? 8. And what's the length of CE? 9. All right, so y'all okay with where my numbers are coming from? Are we sure? Yes. Okay. What I'm going to do next is what do I do next? I'm going to simplify first. What goes into 8 and 12? 4. 4 goes into 8 2 times and 12 3 times. Are we okay? All right, Robert, what do I do next?
You divide 3 by 9.
No. Not. No, I'm going to say it again. I'm going to cross multiply. When I cross multiply, 18 equals 3x. Are we okay? What do I do now? Good. I'm going to divide by 3. My 3's cancel out. I'm left with x equals 6. Are we okay with that? Yes. No, you do not have to simplify, but it makes your life a little bit easier. Are we okay? You okay, Shamar? Okay. All right, here's our second theorem. It's our converse. Who remembers how to find your converse from your conditional statement? Now, instead of opposite, because opposite kind of refers to inverse, we're just going to flip it. So now I'm starting with proportional divided sides, and I'm ending with parallel lines, okay? So here, we're just going to find my divided sides and set up my proportion the same. We're going to set a ratio up with your divided sides and then go across from them and see if both sides are equal. Because what does it mean to be proportional again?
Same
What's the
ratios.
same? Same ratios. Good. Are we okay? All right, let's try one. And this is a cube. All right, so I want LN to be parallel to PQ. So what do I want to happen with my divided sides?
You want them to. Oh, yeah, I get it. It must be the same ratio.
All right, so I'm going to look at my ratios and I'm going to simplify and see if they simplify to the same thing. If they do, I have parallel lines. If they don't, I don't have parallel lines. Are we okay with that? All right, so take your divided side. What segments are formed on this divided side? On this divided side.
LP and PN.
Good, are we okay with that? We're okay?
So it is.
All right, we're going to work the exact same way as we did last time. Pause on that for a second, okay? All right, what's across from LP?
MQ and QN.
MQ, and then across from PN is QN. Are we okay?
Yeah.
All right, plug in what you know.
LP.
LP is,
18.
PN is 16. All right? MQ is what?
27.
27, and QN is,
24.
are we okay? All right, simplify. What goes in 18 and 16?
2.
2. All right, the 7 doesn't go in either of those.
It's not over on.
It's not, or 2. 2 goes into 18 how many times?
9.
And 2 goes into 16.
8.
Are we okay? All right, what do I want? What do I want 27 over 24 to equal?
12.
All right, let's see what happens. What goes into 27 and 24?
3.
3. 3 goes into 27 how many times?
9.
And 24?
8.
All right, so what do I know about my what do I know about my lines? Good. So LM is parallel to PQ. Okay? We're okay? All right, the reason I always draw my arrows is because I might mess this up and say QN over MQ. If that happens, this will be 24 over 27, and this will be 8 over 9. Then I'd mess up my answer from a simple mistake. All right, are we okay with that? So I always draw my arrows so I know where to put what. Any questions so far? And if you do the opposite, you'll be fine, because then you'll do 8 over 9 equals 8 over 9. Do those two numbers still equal? So my lines are still parallel. Are we okay? So that's a good point. I could have started with PN up top, but then I would have had to start with QN up top. Are we okay with that? We're okay?
Yes.
All right, next theorem. All right, you have a question very, very, very similar to this on the test, and a lot of people mess it up when you really, really, really shouldn't. So make sure you're paying attention to this slide, okay? All right, here, instead of dealing with 2 parallel lines like I was in my triangle, I have 3. Do you remember how lines go on and on and on forever?
Yes.
What do you notice is going to happen if I keep extending these 2 lines?
They're going to connect.
They're going to connect, and what are they going to form? A triangle. You okay with that? We're going to approach these the exact same way. On your test, I give you something like... All right, take a second, copy this down. You got, I think it was... Yeah.
Don't get mad. You said we ran. Why you sleep? Oh, playing Call of Duty. Tell Mr. Green.
What the heck?
Jeremy. You ain't getting no work on his feet. Come on now, chill now. My name yesterday, yo. It is. I want to hear it. What doctor said, let's stand for? I'm mad about my dad.
64, yes. I got 51, I got X, I got 36, and I got 64. All right, you got this down? Yeah. Let's do this really quick so SJ can go to the bathroom. Okay, so start with one of your divided sides. What do you want to start with? You want to start with up here? All right, what are my two divided sides? Give me a ratio.
51.
All right, good. So I'm starting with 51. What's across from 51? And what's across from X? Good. Are we okay? How many of you can get that far? Good. All right. What do you think my next step's going to be? I'm going to simplify. What do you think goes into 36 and 64?
12.
Higher than 4. Higher than 8.
No.
Higher than 9. Let's start with 9 though, because that's what I would have seen. All right. 9 goes into 36 how many times? 4. Oops. Uh-oh.
Yes, he is. What'd you do? Oh, gosh, it's all your fault.
All right. 9 goes into 64.
6 times. No,
I think I copied this problem down wrong. That's okay.
63.
Let's do, I don't think 6 goes into, let's do,
7.
it should have been 56. Oh, well, let's see what happens. Let's at least do 2. All right, I don't think this number is going to be pretty. Actually, let's just change this 64 to 56.
Yeah, let's do that.
Yeah. Let's go.
It can go into 9 and 4 or 5.
What the heck, man?
I'm sorry, 54. Let's do 54. Yeah, stop complaining. I'm trying to make this easier for you. All right. Shh. Calm down. Stop. All right. 9 goes into 36 how many times?
4.
9 goes into 54 how many times? 6. So can I simplify anymore? Yeah.
2.
All right. So I'm left with 2/3. We're okay with that?
Yeah.
All right. Cross multiply. What do I get? 2x equals 51 times 3 is 153. Good. I'm just making sure. Calm down. You're absolutely right. Are we okay? All right. What do I do now? What do I do now?
You're going to divide 153 over 2.
All right. So x is going to give me what?
It's going to give you 76.5. 72.
Good.
We need 2.
Are we okay?
We need 2.
No, 71.5.
I got 76. You, okay, hold on.
No, it's 76.5.
Thank you. I thought I was tripping.
Say it was 3 different. Can I go to the bathroom now?
Yes, you can have that.
Thank you.
Last thing for the whole chapter. How's that feel?
Feels amazing. It'll feel even better if you love me back, but you know. That's probably never happened. What?
First of all, what does it mean to be a bisector of an angle? All right, besides cutting it in half. Good. Would you like to explain to the class what angle bisector is?
No. I'm not supposed to do it.
All right. Just like Harlan said, except instead of seconds, I'm going to put angles. All right. I have this ray AD. AD I know is an angle bisector because it splits angle A up into 2 congruent angles. How do I know these 2 angles are congruent? Because of what? Because of my arcs.
Yeah.
Good. Are we okay? All right. If I have an angle bisector, then it divides the opposite side into two segments. What two segments are being divided here? There are four.
A, B,
B, C,
B, D, and DC. Are we okay with that?
yes.
So I know those are going to be proportional to my non-divided sides. So start with your divided sides. BD and DC. Because those are your divided sides. Are we okay with that? All right. Instead of drawing an arrow this time, I'm going to circle the triangle that I'm looking at. If I'm looking at BD, what is my non-divided side that's in the same triangle?
AB. So you're not going to do C?
AB. I'm not going to look at AD because that's part of both triangles, okay?
AB.
All right, so I'm looking at BD. AB is in the same triangle as BD. Are we okay with that? All right, so that comes first. And then I think this is what Cameron's been trying to say all right, this triangle down here has what side attached to it? AC. Good. So I still have my divided side, and I'm not going to draw arrows anymore, but I'm going to circle what triangles are formed by them. Can you visualize what my theorem is saying? My divided sides are proportional to my two non-divided sides. Remember, proportional means my ratios are equal. All right? SJ, leave some room. I'm going to let you copy this down in a second, okay? I'm going to go to the example really quick. Okay, so leave some room. Any questions so far? Okay, let's try an example. I'm going to give you two because one, you got two different kinds on your homework. So copy this down really quick.
What kinds are they?
Y'all calm down. All right. So I'm going to look for what here? I'm going to try and find x, but what do my theorem need to happen? If I had, look back at your theorem. If you had what?
Bisect an angle.
Okay, so if I have an angle bisector, do I have an angle bisector here?
No.
Yes, you do.
Yeah, what two angles are congruent?
AD and DC.
All right, those are segments A, B, D, and good. All right, so I have an angle bisector. We okay? All right, what am I going to start with?
Your divided side.
Good, I'm going to start with my divided sides. Give me the segment names.
A,
Perfect. Are we okay?
Yeah.
All right, what segment is attached to AD?
AB.
AB, good. All right, and what segment's attached to DC? Good, so I know AB over BC is on the other side of my ratio. Are we okay? All right, plug and chug. Plug in what you know. What's the length of AD?
8 over 8.
Good. All right, I'm personally going to simplify first. What goes into 4 and 6? 2. Now I'm going to cross multiply with 3 times 8.
24 times 2.
2/3.
Yeah, we're good. We're good. You okay? All right, then we cross multiplied. Are we okay? Good. Divide by 2.
X
She keeps saying 2/3.
I did different.
How'd you do it? You just looked at it and said that's double that, so it has to be double that.
And then X over 6.
That's okay. It's just make sure you keep in corresponding parts together, okay? All right, any questions so far?
No.
All right, last example, then we'll start our homework.
You mean finish it? I'm already done with one. She's like, whoa.
Yeah.
All right, if you start with your segment names, you're likely to not mess it up. All right, what segments are my divided sides?
B and DC.
Good. Are we okay?
Yeah.
All right, what are my corresponding parts with it? What's attached to the triangle?
And AC.
Good. AB over AC. Any questions so far? Nothing's different here.
No.
All right,
Nothing at all.
I want y'all to think about something. If we had a segment, and I knew my whole segment was 28, and this was 10, What would be the length of this segment here?
18.
Why?
Because
Because
it's
it's half.
Not half. How'd you get it? How'd you get 18?
Subtract 28.
two segments.
10.
I'm not dividing.
10 from 28.
Good, yeah. We're going to
Yeah,
take
you
28
said
minus
five.
10 and we get 18, right?
Right?
Are we okay? Y'all can do it in your head. You're just having a hard time talking about it. But you're okay with that?
Yeah.
All right, so let's forget about this really quick. All right. So if I'm looking at BD here, at just this segment, how am I going to find it?
Multiply.
Think back to the one we just did. If I had 28 and I had 10, what did I do to get the other segment? All right, so take your whole segment. What is that?
28.
28. And what are we going to subtract from 28?
8.
Do we have any questions on that?
Obviously.
Taking 28. What do I need to take away from 8? Okay, that's all I've done so far. Are we okay?
Yeah.
All right, what's the length of DC? What's the length of DC? Good. All right, what's the length of AB?
8.
And what's the length of AC? Good. Any questions so far?
No.
Can't you simplify 8 over 24?
Absolutely. What am I going to simplify 8 over 24 to?
1/3.
1/3.
All right, and I'm going to do one more thing before I cross multiply. Who remembers what it is?
The parentheses around.
Parentheses. Good.
Smart, yeah.
Are we okay?
That is smart.
Okay?
I forgot.
Any questions so far?
No.
Can y'all read that? Is it too small?
Yes.
Y'all can read it?
Yeah.
All right. What am I going to do now? Cross multiply. When I cross multiply this, what do I get? All right, cross multiply this, what do I get? Good. Are we okay so far?
Yeah.
Can you read that purple?
Yeah.
Kind of. What was that?
He said, what's that for?
What's your body count?
Good, okay. How do I approach this problem? What do I do now?
Distribute.
Good, let's distribute. What's 3 times 28?
84.
Good. 84 minus. Perfect equals. All right, now what?
Plus 3x.
That's,
And then you get
That's what you want.
84 equals 4x. And then you divide 4. And then you get 21.
Perfect. All right, was that bad?
No.
No. You can do this, okay?
No, erase that.
I'm not.